Hi guys, we're screencasting again today. This is a two-part section. The first part we're going to do like this. You're going to follow along with the notes along with the video. Please take the notes. What I am writing, I would like you to write. Please work out the problems. Don't skip steps. I will be checking, especially when it comes to the monitoring progress problems. Please show your work. You will see the answers. I will ask you to pause the video and work them out. When you play the video again, you will see the solutions, but the work doesn't show, so you need to show the work. Today we're working on how to solve an absolute value equation. This is the mathy stuff. Okay, so you're used to seeing this stuff, the mathy stuff, and it's just definitions. I want you to realize, first of all, you can circle it or highlight it somehow, that whenever we have an absolute value, whatever comes out of that absolute value will never be less than 0. Now, sometimes we may have an opposite sign there, but whatever comes out of an absolute value sign is never 0 or never a negative number, because we're dealing with distance from 0. That's actually what absolute value is the distance away from 0. The next thing is, please realize that if we have something inside of an absolute value sign, one is a negative, one is a positive. An example might be here if this were a -2 and a +2. Those are both going to end up being the same, because again, whatever comes out of the absolute value sign is going to be the positive. Numbers 3 and 4 are just for your own information at the moment. Let's look at the solving absolute value equations. This is the part that is the mathy explanation of what we're going to do. The main thing is, I want you to recognize that here on the right-hand side, when we're solving them, we get rid of the absolute value brackets here and here. And what we do is we simply change the sign. We simply just change the sign, and please write this, of the right side. So one is going to be positive and the other is going to be negative. What happens is, with absolute value equations, you will have two solutions. When I taught this last year, I used the little phrase, one equation, okay, becomes two solutions. So that ties in with what we have been doing with special solutions. Let's go to the next page. Let's do these examples. This is example number 1. One equation is going to become two solutions, so I'm going to go ahead and write kind of a little squiggly line here. What I am going to do is I'm going to get rid of, if you remember the strategy, I'm going to get rid of these brackets, and instead of writing the brackets, I'm just going to say this, x minus 4 equals a +6, or this little line kind of means an or, x minus 4 equals a -6. If you'll notice, all I did is I got rid of the brackets and I changed the sign. One's a positive, one's a negative. So let's solve these two equations now. Add 4, add 4. These cancel, x equals 10. Let's do the same thing over here. Add 4, add 4. These cancel, x equals -2. So in this case, one equation, okay, just one equation right here, became two solutions. And we write this as x equals 10 or x equals -2. Let's work on this second one. Remember, the strategy is get rid of the brackets, so 3x plus 1 equals -5. Okay, now here is the case where we have something that is negative here, meaning the opposite of, but I'm going to put the stop sign up, stop sign. Okay, what do we know about an absolute value? Okay, we know that an absolute value sign cannot be a negative number. That is not allowed because it's talking about distance from 0. So this has no solutions. Now, what I want you to recognize is that this is true. There are no solutions when this on this right-hand side is only a constant term, like a -1 or a -100 or a -1,267. If you had anything else over here, if you had an x minus 5 or a y minus 5, then it still could work out. So make sure that you know that there are no solutions only when this is a negative constant term, just a number. Now please work out numbers 1, 2, and 3. One of these is no solutions. I'm hoping you can recognize it right away. Again, for no solutions, you're recognizing something that has just a negative number or constant term on the right-hand side. Please pause the video and work them out. Here are your answers. In the first case, okay, in the first case here, see if we can get this to work. This is being okay, for number 1, x equals -10 and +10. I was trying to get it to work, so that's why there's red dots all over. In the second case, we have, again, there we go, x equals -3 or x equals 5. And in the last case, we have, come on, bang, no solutions. There are no solutions to this one, no solutions. Let's go to the next slide. This is example number 2. Example 2. Okay, now this creates a little bit of complexity. We're going to solve it the same way, but we have something to deal with. We have to make sure that whatever is inside the absolute value sign is all by itself on the whatever side it is before we solve it. So I'm going to write a little note. I'm going to do a little asterisk. I'd like you to do that as well. And you're going to say, make sure. That's a U. It's not make sure, it's make sure. The absolute value sign is by itself. So what we may need to do, and we're going to have to do it in this case, is we are going to have to, unfortunately, do a little bit of work here to get the -10 to the other side. So what I am going to do is I'm going to add 10 to both sides. The only reason I'm doing that is to get that -10 to the other side. This becomes the absolute value of 3x plus 9 equals a +6. Now we can solve this. All right, so that's, sometimes you have to do a little bit of manipulation, and the key there would be make sure that absolute value sign is all by itself. One equation becomes 2 here. This is 3x plus 9 equals a +6, or 3x plus 9 equals a -6. Remember, the key here is just simply change the sign on the right-hand side of the equation. One is positive, one is negative. Let's solve. -9 minus 9, and this becomes 3x equals -3. Divide by 3, divide by a +3, and x equals -1. Let's finish the other side. -9 minus 9. Okay, these cancel. 3x equals a -15. Divide by 3, divide by 3, x equals -5. So x equals -1 or x equals -5. And if I am going too fast, then what you would need to do is just pause the video to make sure you can catch up. We're going to skip this problem. What I would like you to do, please, is go ahead and pause the video. And I would like you to please work out 4 and 5. Don't work out number 6, just 4 and 5, please. Okay, so the answers for 4 and 5. Let's see if we can get this to work without beating it up. There we go. That's lovely. You can't even see it. X equals -2 and x equals 6. And then for the second one, number 5, still not working. is it not working? There it is. X equals negative 5.5 and a negative 1.5. Don't worry about 6 and 7. Those are things we're going to do together at a later date. We're going to finish with this concept and the example that goes along with it. Sometimes we have absolute values on both sides of the equal sign. So what I'm going to do is just point out that now we have absolute value here and here. All right, the cool thing is you do it exactly the same way. All right, I'm going to turn this into a pen. If you'll notice, this is the positive version, and if you'll notice, this is the negative version. So you still do the same exact thing. One side, or on one side, right side, it's positive, on the other is negative. So the only thing you have to watch out for is you do have to check your roots. So I want you to put a little asterisk, and I want you to say check your solutions. Now, I'm not going to explain in detail yet why you have to do that. You end up getting extraneous roots, which we're going to cover tomorrow. All right, in your notes, all you have is letter B. So let's just do letter B together. Now, remember, you're going to solve this exactly the same way that you do. We're going to, in this case, put a little note to yourself, and I want you to say replace the brackets with parentheses. And that makes it a little easier because, especially on the right-hand side, we have a quantity to multiply. We have to distribute. So one equation becomes 2. We are going to say 4x minus 10 equals 2 times 3x plus 1. Okay, now remember, it's the same exact strategy. Okay, this is a positive 2 here. So on the flip side, on the other side, I have 4x minus 10 equals a negative 2 times the quantity 3x plus 1. So on one side it's a positive, on the other it's a negative. Now we just proceed and solve them just like normal. Here on the left I'm going to get rid of my parentheses for now because I'm not multiplying them times anything, but I do have to distribute. This is going to be 6x plus 2, and I'm going to solve. 6 is my bigger number here, so I'm going to subtract 4x from both sides. These cancel. I get a negative 10 equals 2x plus 2. I'm going to subtract 2 from both sides. Okay, and that's a negative 12 equals 2x. And finally, dividing by 2, x equals negative 6. Let's do this second equation. Get rid of the parentheses here on the left because there's nothing I'm multiplying it times. But I have to distribute this negative 2 to both things inside, negative 6x minus 2. Now in this case, the 4 is the larger of the two coefficients for my variable term, so I'm going to add 6x to both sides. This cancels, and I end up over here with 10x minus 10 equals negative 2. Add 10 to both sides, cancels. So 10x equals 8, and finally divide by 10, x equals 8/10. And we simplify that by reducing it, divide by 2, top and bottom, and we end up with 4/5. We still have two solutions, x equals negative 6, okay? Or we have x equals 4/5. But the thing is, if you remember, we have to check these. So check. We're going to check x equals negative 6 for our example. Just for lack of time, that's the only one we're going to check, but you would have to check both. You'll get more explanation tomorrow, but the thing is you need to look for what's called extraneous roots. So to check it, you plug it in. So I am going to say 4 times negative 6 minus 10, and all of that's inside the absolute value sign. Then I have a 2 here, sneaking the 2 in. 3 times negative 6 plus 1 in absolute value sign. This becomes negative 24 minus 10 equals 2 times negative 18 plus 1. Simplifying a little more, negative 34 equals 2 times negative 17. Now the thing is, when it comes out of the absolute value sign, it's positive. So 34 equals 2 times positive 17. 34 equals 34. That solution works. If you were to check x, okay, check x equals 4/5 and plug it in also, you would see that it works. It is kind of a long example. It does work. So there are no extraneous roots here. Tomorrow we worry about extraneous roots. All right, for your last example, I would like you please to do just number 8. So please work it out and then pause the video. Well, pause the video and then work it out, and you will have the answer in just a moment. All right, so x equals -3 and x equals 7 are your answers. Thank you for watching. And if you have questions, please ask.